Hello everyone. Welcome to our channel, the Digital Institute of Computing Technology. In this presentation we will have discussion on the topic file handling in Python programming language. A file is a container in a computer system for storing data or information. Files can contain a variety of data types, including text, images, audio, video, and software programs. Files are identified by file names and usually have extensions that indicate their type, such as .text for text files, .jpg for images, or .axa for executable files. Example, such as data.txt, image.jpg, video.mp4, audio.mp3, etc. A text file typically contains readable characters and can be opened and edited with text editors, like Notepad, TextEdit, or more advanced editors like VS Code. A binary file contains data in binary format and is not human readable. It can store various types of data such as images, videos, executable, or any other non-text data. Using Python built-in functions you can perform various operations on these files. You can open these files and perform operations on them such as reading, writing, appending, etc. and close these files after use. Let's have a detailed discussion with examples. Firstly, let's see the open operation. Opening a file. In order to access the contents of the file you need to open the file first. You can open a file using the open function. The open function takes two parameters. The parameters are the file name and the mode in which the file should be opened. You can see the various modes in which a file could be opened. Let's see the different mode in which a file could be opened and the mode parameter required for the open function. Mode parameter R implies open for reading. This is the default mode. Mode parameter W implies open for writing, truncating the file first. Mode parameter X implies create a new file and open it for writing. If the file already exists, throw in error. Mode parameter U implies open a file for writing, appending to the end of the file if it exists. Mode parameter B implies open in binary mode. Mode parameter T implies open in text mode. This is the default file type. Mode parameter plus implies open a disk file for updating, both reading and writing. Reading from a file. To read a file you need to open the file in read mode. Let's open a file with name source. For reading, it is a text file and R indicates that we are opening the file for reading. Once the file is opened, we are assigning the file object to variable rf. Then, we are reading the contents of the file using a call to built-in file read function. rf.read and assigning the contents to variable cnt. Finally, we are closing the file. Now, we can process the content of the file, which is now present in CNT. Let's assume we want to convert all the characters in the file to uppercase. We can convert the contents of variable CNT to uppercase using the strings upper function. pcnt assigned cnt.upper will convert the letters in CNT to uppercase. Finally, the uppercase letters are stored in variable pcnt. Now, let's open another file with name dst. For writing, it is a text file and W indicates that we are opening the file for writing. Once the file is opened, we are assigning the file object to variable wf. Then, we are writing the contents of the pcnt to the file, using a call to built-in file write function. wf.write. Finally, we are closing the file. So, we have seen a simple example on how to open a file in read mode and read its contents in a variable and close it. Then process the file contents stored in the variable and finally, open another file in write mode, and write the processed contents to this file. In both cases we had to close the files explicitly. Using the close function, we can use a with operator to avoid explicit close. The with operator ensures that file is closed automatically once you exit its body. This is how the code looks when you try to use the with operator for opening a file. Here, the file is closed automatically once the control goes out of the with block. The with block internally takes care of closing all the files in its block during exit. Now, let's try to process a binary file. Let's open a file with name source.bin. For reading, it is a binary file and R indicates that we are opening the file for reading. Once the file is opened, we are assigning the file object to variable rf. Then, we are reading the contents of the file using a call to built-in file read function. rf.read and assigning the contents to variable bcnt. Now, let's try to process the binary content by inverting the bits for the entire contents of a file. Here is the logic. The variable pbcnt is of type byte array, a data type to process the data in binary. Using a for loop, we are accessing every byte in this byte array and inverting its bits. Now, at the end of the loop, we will have the inverted bits in the byte array pbcnt, which we will write to the binary file dst.bin. Now, let's open another file with name dst.bin. For writing, it is a binary file and W indicates that we are opening the file for writing. Once the file is opened, we are assigning the file object to variable wf. Then, we are writing the contents of the pbcnt to the file using a call to built-in file write function, wf.write. This way you can process file of any type using Python's file functions. As you can see, while processing both the text file and the binary file, with respect to file operations, only the file name has changed and everything remains same. Now, let's open a file with name example1. For appending, it is a text file and indicates that we are opening the file for appending. Once the file is opened, we are assigning the file object to variable file. Then, we are appending a line with contents. A new line has been added, followed by a /n to the file using a call to built-in file write function. Suppose the file example1 just had one line. Assume the line is, the file has one line, as shown. After appending another line, say the line is, appending the new line. The contents of the file will be, as shown. The file has one line. Appending a new line. Similarly, you can open a file and read its contents line by line using a for loop. Now, let's open the same file. Used in previous example for reading, R indicates that we are opening the file for reading. Once the file is opened, we are assigning the file object to variable file. Now, using for loop we are accessing the file contents line by line and printing it. The output in this case is reading line by line. The file has one line. Appending a new line. The first line in the output is from the print statement and then the contents of the file is displayed, line by line. Now let's see the different mode combinations for the open function. Mode parameter RB implies open for reading in binary mode. Mode parameter WB implies open for writing in binary mode. Truncating the file first. Mode parameter XB implies create a new file and open it for writing in binary mode. If the file exists, throw an error. Mode parameter AB implies open for writing in binary mode. Appending to the end of the file if it exists. Mode parameter R+ implies open for reading and writing. The file must exist. Mode parameter W+, implies open for reading and writing. Truncating the file first. Mode parameter A+, implies open for reading and writing. Appending to the end of the file if it exists. Mode parameter RB+, implies open for reading and writing in binary mode. Mode parameter WB+, implies open for reading and writing in binary mode. Truncating the file first. Mode parameter AB+, implies open for reading and writing in binary mode. Appending to the end of the file if it exists. Now, let's discuss the different functions for file operations that the Python language provides. Python provides a rich set of functions and methods for file operations. Below is a comprehensive list of the most commonly used functions and methods related to file handling in Python, along with brief descriptions and examples. The open function receives two parameters, file name and the mode. Opens a file and returns a file object. Mode specifies the mode in which the file is opened. Example: open the text file example.txt in the read mode. Assign the file object returned to the variable file. The close function closes the file. Syntax is file.close. Reading from a file. File.read. Reads up to size bytes from the file. If size is not specified or is negative, reads the entire file. Example: content assigned file.read. File.readLine reads a single line from the file. If size is specified, reads up to size bytes. Example: line assigned file.readLine. File.readLines reads all lines in the file and returns them as a list of strings. If hint is specified, reads up to hint lines. Example: lines assigned file.readLines. File.readInto reads bytes into a pre-allocated buffer. Example: file.readInto ARR buffer. ARR is a buffer that could be created by importing array module. Writing to a file. File.writeString writes the string to the file and returns the number of characters written. Example: file.write hello world. File.writeLines writes a list of strings to the file. Example: file.writeLines of first line with /n, then second line with /n. Moving the file cursor. File.seek moves the file cursor to a specified location. Parameter whence can have values 0, 1, 2. 0 means beginning of the file. It is default value. 1 means current file position. 2 means end of the file. Example: file.seek of 0 will move the cursor to the start of the file. File.tell returns the current file position. Example: position assigned file.tell returns the current file position that can be saved in the variable position. Flushing and truncating. File.flush flushes the internal buffer, writing the data to the file. Example: file.flush. File.truncate truncates the file to a specified size. If size is not specified, truncates to the current file position. Example: file.truncate 10 will truncate the file to 10 bytes. Checking file status. File.closed returns true if the file is closed. File.mode returns the mode in which the file was opened. Example: mode assigned file.mode. File.name returns the name of the file. File.encoding returns the encoding used to open the file. Only available in text mode. Let's write a simple Python script to demonstrate checking file properties on file example.txt. Open the file in read mode and then display the file mode, file name and the encoding. File.mode will provide us the mode of the file. File.name will provide us the name of the file. File.encoding will provide us the encoding of the file. The output in this case is file mode, R, file name, example.txt, file encoding, UTF-8. Suppose the file example.txt has 2 lines. Assume the lines are as shown. Let's open the file example.txt for both reading and writing and perform some operations. First, we are reading the existing content of the file. The line file.seq of 0,2 will move the cursor to the end of the file. Then, the write operation will move the cursor to the next line with /n and then write the text. New content added. The contents get added to the end of the file. Because previously we used the seq operation to move the cursor to the end of the file. Again, the line file.seq of 0 will move the cursor to the beginning of the file. At last, we are reading the new content of the file. The output in this case is before write. This is for demonstrating how to use file functions. After write. This is for demonstrating how to use file functions. New content added. The lines before write and after write are from print function and rest of the data is file contents. You can see, after write operation, the line, new content added, has been appended. Let's have one more comprehensive example that combines reading and writing, along with exception handling. In this example, the file is first opened in read mode, then we read its contents in print. Next, the file is reopened in append mode to add a new line. Next, we test the function process_file by invoking it with filename example.txt. The output in this case is file content. This is for demonstrating how to use file functions. Additional line added. Line appended to the file. File operation completed. The characters in bold are the contents of the file example.txt. Here, exceptions are handled for scenarios where the file might not exist or other I/O error occurs. 2 exceptions have been handled here. File not found error exception and I/O error exception. The finally block ensures that a message is printed regardless of whether an exception was raised or not. These examples cover the basic file operations in Python, providing a foundation for more complex file handling tasks. So, this covers an overview of files and how to handle files using built-in file functions in Python programming language. Hope you enjoyed and liked the presentation. Remain connected with us by subscribing to this channel for latest updates on this channel. Thank you.